Okay, here we go. Our fifth note, our lesson on motion, is probably the most calculations you'll have to do all course. That makes you feel better or worse, I don't know. But basically, I gave you a formula for acceleration last lesson, A equals V2 minus V1 over T. The truth is, there's 5 different formulas that can be used for non-uniform motion or accelerated motion. And sometimes they have a distance in them, or take that back, displacement. I use just D because I'm lazy and all the typing, and I'll let you be lazy too, as long as you and I both agree to that the D's, when we're doing these accelerated motion formula, are displacements. Okay, so here is one of them. Okay, D equals this. These two here are the exact same formula written out, isolating V1 instead of D, or isolating A instead of D. Okay, so these are really the same formula. This is the new formula I'm showing you right now. And different times we have to choose different formulas. There's also, for our point of view, sometimes we'll solve for time. If the only time we'll do it in this class is if V1 is 0. And the reason I say that is, if you look at this formula, if V1 isn't 0, this is a quadratic formula and we're solving a quadratic, and not that you're not capable of that, it's just a level of math complexity we don't bother with in this class, okay? But so we certainly can use this formula if V1 is 10 or 20 or 15.3, but it involves using a quadratic, which we're just not going to do in this class, okay? So if you're given V1 is 0, then, and you're solving for time, you use this formula here, okay? If V1 is not 0, then I don't intend for you to use this formula, okay? And in which case you wouldn't be able to use this one, okay? So just looking at it again, so here's a new formula. This is me writing the formula as getting V1 or A by itself instead of D, because you might be solving for V1 or A, or in this case T. So let's use the formula, okay? And we're looking at good communication and all that. First starts from a rest and he accelerates at 4 meters per second squared. So that must be my acceleration because I got that squared there, for 3 seconds. How far does he travel? The how far must be D, or displacement. Okay, so rest, V1 must be 0. Like I say, the only accelerates at 4 meters per second squared, so that must be my A. T is the seconds, right? And we're looking for D. So this is going to be using that formula, just, just subbing in, right? So we write down our formula, okay? You sub in the numbers. Remember, 0 times 3 will just be 0. If you just put this into your calculator, like, I really like Google Calc, so if I was going to type this in, you could type it in just like it looks, but you end up with 18. Again, if I want to check mark that, is 18 a good number? Probably. We don't really know what Ferd's doing, but it's a realistic number, right? He's 3 seconds, he's got a big acceleration, makes sense that he might travel 18 meters. It's a reasonable number, okay? So that's using that formula there. I have 3 other formulas to show you, okay? This one looks a lot like it, but just look at the difference. This one has V1 in it. This one has V2, and it's a subtract, okay? If instead of, here's the 2 rearranged forms. So again, these are the same formula, just written differently, okay? And here's the, if you have V2 is 0, you can use that formula like that. So by the way, I'm going fast with the assumption that you're pausing to write down stuff if you need to. So looking at the example problem, how long will it take Ferd to come to a full stop if he travels 30 meters with an acceleration of -2? So he's coming to a stop. So he's slowing down, obviously, right? So V2 is 0, coming to a full stop. So that sort of implies he's not starting at a stop, he's finishing. So V2 is 0, acceleration is the negative. T is what we're looking for, is how long. That usually means how long here, generally how long means a time. And he does it in 30 meters, okay? So we're going to use that formula. So again, how long will it take? So I'm looking for T, right? So It's going to have to be this one, and I can use it because V2 is 0. Okay, so it doesn't look that great, but you sub in the numbers. Notice, you might have been nervous when you saw the negative under the square root there, but it will imply, because V2 is 0, it will imply a negative acceleration. So the negative turns into a positive, okay? And 5.3 seconds, which I think is a pretty reasonable number, whatever it is he's doing. Travel 30 meters, 5 seconds. We have no idea what speed he started at. It doesn't matter. Okay, so that's using that formula. And again, I've just chosen this particular version of it, but depending on what you're looking for, you might take it from one of these forms. And that's what you got to get good at. That's the skill, that's the practice you need to get, is sort of which form of the equation, subbing in. You'll get some practice on that. Okay, there's another formula. Notice this one doesn't have a t in it. No time. And that's, by the way, the idea. All these formulas can be used to describe the same motion. But when you're solving a question, you're looking at a problem, sometimes you can't, like if we don't know anything about time, then this is a good formula to use. If you're given a question and there's no time given and you're looking for distance, you can't use this formula. It won't work, right? And so you have to get into the idea of picking a formula that goes with the givens you have. And we'll talk about that a bit more later. For now, let's just look at this formula here. There's those rearranged forms. Okay, so if instead I'm looking for V1, or I'm looking for A, or I'm looking for D, those are the rearranged forms. And then here's the example. So Ferd's accelerating. We have a distance, so D is 15 meters. We have an acceleration of 1.5 meters per second squared, and he's got a V1. What's his final velocity? So I'm looking for final velocity, so I'm looking for V2, right? So I'm going to use this form of the equation. And, you sub in the numbers. V2 squared is 2 squared plus, at the end, don't forget to take the square root, because really this is solving for V2 squared, not just V. So it ends up being 49, so 7 meters per second, which he's starting at 2 meters per second. He's, accelerating over a short distance. 7 seems like a reasonable number, right? Okay, so that's using our fourth of 5 equations. We have one more equation. Here she goes. This one. Now look at this formula. This formula has no acceleration in it. None. So we're given, it'll be a question where you don't know acceleration, which if you choose the lab for this, by the way, there's 2 choices of activities for your assignment. It's either to do some practice questions, like problems, or there's a lab. And in the lab, you don't know acceleration because it's hard to know acceleration, right? But you can figure out things in this equation. Anyway, this one we're saying Ferd slides to a rest over a distance of 12 meters and 2.5 seconds. What's his starting velocity? Okay, so he's sliding to a rest. Keep note of this one though, but this is just like your lab, okay? This one's just like your lab. So something's sliding to a rest. We know a distance and we know a time. What's the starting velocity? In the lab, kids, when I give this question to kids always take that distance and time and divide and get an average velocity. It's not the same, right? Because the starting velocity would be really fast. The ending velocity is 0. So that's an important thing to know. But anyway, there's the use of that equation. So we're looking for V1, so you'd use this form right here. We know V2 is 0. So basically it's 2 times 12 minus 0 over 2.5. Put that in your calculator. You should get 9.6, which is, again, pretty fast, but not an unreasonable number, 10 meters per second. In terms of kilometers per hour, he was going then 35 kilometers per hour. Maybe he's on his bicycle or something like that. Anyway, so that's using that formula, and that's all. Those are all the formulas I got to teach you as far as motion is concerned. Okay. there's the bunch of them, and now it's a matter of figuring out, like, again, that question is, how do I know which one to pick? Well, and the short answer is whichever one works. They're all perfectly fine equations for accelerated motion. It's just a matter of, do you have the givens? Can you use the formula? So what you generally do, say you're given a set, say you've worked out your problem, you've listed the givens, this is them. What you have to do is notice what's not in the formula, or sorry, what's not listed here. And so when I listed my givens, I listed what I'm looking for, I didn't list an A. So the formula you choose has to be the one without an A in it. Okay, so you choose the formula without an A, and then you, in this case, this is the question from the last one, right? And then you just you pick the form that's rearranged for you, right? So you'd pick this form of that equation. So it's a lot, but you can do this. So the thing then to keep in mind is when you're, how do you know which equation to use? Well, if you're given a situation, so here's all the equations we've learned, there's 5 of them, and there's no displacement or nothing about distance listed at all, right? Well, then you choose this equation. If there's nothing listed about the final velocity, you choose this one because there's no v2 in that equation. And so choosing the formula becomes a matter of what you don't know instead of what you do know. Okay? This one, there's no time listed, so you find like in a question, if they don't tell you anything about time, you choose the one that has no time in it, assuming that you're looking for one of those things. Now, if you're looking for time, that's different, right? So that's why you list what you're given, you list what you're looking for, and then you go from that list, and if you don't write down acceleration, use this formula. Okay, so it takes a bit of practice. You'll see them on the quiz, and then your 2 choices for the activities is either, I think it's about 3 or 4 problems where you practice choosing the right equation, or you can try the lab. Okay, that's it.